Welcome to this video. This video is going to be an educational video on the narcotic drug cocaine, and it's intended to be understandable by anybody. Okay, so the first thing I want to do then is outline what questions are we going to aim to answer in this video before we then begin. Okay, so the first question we're going to aim to answer in this video is what actually is cocaine? Then what we'll talk about is what are the different routes of administration for cocaine. Okay, so we'll look at the powder versus crack cocaine. So what's the difference between the powder form of cocaine and the crack form of cocaine? Then what we'll do is we'll look at how cocaine actually achieves its effects. Okay, and specifically we'll focus in on the brain. Okay, so cocaine has effects on the whole body, but we will just be looking at what effects does it have on the brain, because that is what most people are most interested about. Okay, and then finally what we'll look at is what is understood about how cocaine actually achieves these effects on the brain. Okay, so firstly then we want to ask the question, what actually is cocaine? So cocaine is a name given to a certain molecule. Okay, and it's a very small molecule. So what I now want to do is put up a formula for cocaine which will hopefully illustrate that it is just a molecule. Now I'm not going to draw out the full structure of cocaine because that's quite complicated to look at, and it's not particularly actually that helpful for understanding how cocaine works. But I do want to put up a formula just to emphasize the point that it is just a molecule. Okay, so I'm going to put up a formula that will tell us what the atomic constituents of cocaine actually are. So C17 H21 NO4 is a formula for cocaine, and what this formula tells us is what the actual atomic constituents of cocaine are. So the C17 here tells us that cocaine contains 17 carbon atoms, so every cocaine molecule contains 17 carbon atoms. The H21 here tells us that every cocaine molecule contains 21 hydrogen atoms. The N here tells us that each cocaine molecule contains 1 nitrogen atom. And finally, the O4 here tells us that each cocaine molecule contains 4 oxygen atoms. Okay, so this tells us the atomic constituents of cocaine. Okay, now this does not completely specify cocaine. This just tells us how many atoms of each type you need to build a cocaine molecule. But really, to specify what cocaine is, you need to also know how these are actually bound to one another. Okay, so you need to know the actual arrangement of these in the molecule. Okay, because there's loads of different ways that you could arrange these, and that wouldn't be a molecule of cocaine. So this formula alone doesn't tell you that you're working with cocaine. You have to also know how these are actually arranged as an overall structure. Okay, now we're not going to go through how all of these atoms are actually arranged because, as I say, it's complicated and it isn't actually that important for understanding how cocaine works. But I've put this formula up just to illustrate that it is just a small molecule, okay, made up of these atoms. Okay, so that's the answer then as to what cocaine is. Next, what I want to address is, where does cocaine actually come from? Where do we actually get it? Okay, well, chemists can synthesize cocaine. You can make it by performing chemical reactions involving other molecules. Okay, so you can artificially synthesize cocaine. However, that's not the main source of cocaine. The main source of cocaine is from nature. Okay, we get it from a plant. Okay, and the specific plant that we get cocaine from is called the coca plant. Okay, and this is a plant which grows in portions of southern America. Okay, and the leaves of this plant contain a lot of this molecule cocaine. So what you can do is you can collect the leaves of the coca plant and then extract the cocaine from those leaves, and that is the main way that cocaine is actually produced. Okay, now there's an interesting side story here concerning Coca-Cola. Okay, so Coca-Cola, the fizzy drink, has been produced now for over 100 years. So it was set up in the 19th century. And the reason it's called Coca-Cola is because it does actually contain extract from the coca leaves of the coca plant. Okay, so the coca here is the same coca as we've got in the coca plant here. Okay, so Coca-Cola, when they originally were designing Coca-Cola, they wanted to put in coca leaf extract. And of course, when you put in coca leaf extract, you end up with cocaine in the Coca-Cola as well. So when Coca-Cola was first produced in the 19th century, it did actually contain molecules of cocaine because it contained the coca leaf extract. Okay, now, Coca-Cola no longer contains cocaine. It hasn't contained cocaine for a very, very long time, since society's view of cocaine changed to a rather more damning view, and then Coca-Cola thought that it was wise to remove the cocaine from the coca leaf extract. However, Coca-Cola is still made, I believe, with the coca leaf extract. Okay, and the way this now works is that the factories for Coca-Cola are in America, and of course cocaine is highly illegal in America, so how do the Coca-Cola factories get permission to use the coca leaves? Well, what I believe happens is that the coca leaves are grown in portions of Southern America, and then they are taken into the United States, where they firstly go to a lab which extracts all of the cocaine from the coca leaves, and then that cocaine is used for medicinal purposes. And then what they do is they send to the Coca-Cola factories the leftovers of the coca leaves. So once they've extracted all of the cocaine from the coca leaves, they send what is left of the coca leaves to the Coca-Cola factories, and then the Coca-Cola factories get a coca leaf extract which they can use to make their Coca-Cola, and it does not contain cocaine. Okay, so Coca-Cola no longer contains detectable levels of cocaine. Of course, no purification process is perfect. This extraction process where the lab removes the cocaine from the coca leaves will not get absolutely every single molecule of cocaine. So some molecules of cocaine will end up in the Coca-Cola, but it's not detectable levels. Okay, so to all extents and purposes, Coca-Cola does not contain cocaine. The reason it gives you a stimulant effect is because it contains a huge amount of caffeine, not because it contains a few molecules of cocaine. Okay, so that's an interesting side story concerning the coca plant, however. Okay, right, so there we have what is cocaine and where do we actually get it from. Let's now talk about the different routes of administration, okay, available for cocaine abusers. Okay, so I want to talk about what the difference between the white powder form of cocaine and crack cocaine actually is. Okay, so we'll start off with the powder and then we'll talk about crack cocaine. So there are two forms that cocaine is mainly used in, the powder form and crack. So let's start off discussing the powder form here. Okay, so the powder form isn't actually the molecule cocaine on its own. Instead, the powder form actually contains a molecule called cocaine hydrochloride. Okay, and I just want to give a basic explanation as to how you modify cocaine to make it into cocaine hydrochloride. Okay, so to turn a cocaine molecule into a cocaine hydrochloride molecule, what you have to do is bind the cocaine molecule with a hydrogen chloride molecule. Okay, so let me just explain firstly what is hydrogen chloride. Okay, so hydrogen chloride is an extremely simple molecule. It just contains two atoms. It contains a hydrogen atom and a chlorine atom, and these two are bound together. Okay, now, what can happen then is you can bind a hydrogen chloride molecule to a cocaine molecule. Okay, now, it's important here to stress that there are different levels of chemical bond. Okay, the bonds between the atoms of a cocaine molecule are very strong bonds. What we're about to form this bond between a cocaine molecule and a hydrogen chloride molecule is going to be a very weak bond. Okay, but nevertheless it is going to be a bond. Okay, so what you do is you take a cocaine molecule, you take a hydrogen chloride molecule, and these two combine together, but in a weak way, in a very easily reversed way. Okay, so a cocaine hydrochloride molecule can very easily dissociate again back into a cocaine molecule and a hydrogen chloride molecule. Okay, so cocaine hydrochloride can very easily break down to produce you cocaine. Okay, so this is a weak bond between the cocaine and the hydrogen chloride molecule. Okay, so the powder form then of cocaine actually contains cocaine hydrochloride. Now, how then is cocaine hydrochloride actually taken? Well, famously, it can be snorted, okay, or another word for it is snuffed, okay, so it can be inhaled into the nasal cavity, okay, and then it coats the nasal epithelium and then is absorbed into the bloodstream across the nasal epithelium. So the nasal epithelium is the mucous membrane lining the inside of your nose, basically. Okay, so go up your nostrils, you have a cavity called the nasal cavity, and the surface of your body lining this cavity is called the nasal epithelium. Okay, so the cocaine hydrochloride powder covers the nasal epithelium, and then is going to be absorbed into the blood across the nasal epithelium. Okay, so that's one route of administration for cocaine hydrochloride. Another route of administration for cocaine hydrochloride is that it can be dissolved in water and then injected into the bloodstream, so it can be injected intravenously, IV. Okay, so cocaine hydrochloride dissolves very readily in water and then can be just injected into the bloodstream, and that will of course also get it into your bloodstream. Now, importantly, remember, cocaine hydrochloride very easily breaks down back into the cocaine and the hydrogen chloride. Okay, so when you get cocaine hydrochloride into your bloodstream, it will also mean that you're going to get cocaine molecules into your bloodstream, because the cocaine hydrogen chloride can break down back into cocaine and hydrogen chloride. Okay, and then what will happen is the cocaine molecules can then cross in from the bloodstream into your brain. So you've delivered cocaine into your bloodstream and to your brain through this route. Okay, right. Now, cocaine hydrochloride is not as popular as crack cocaine, and there's two main reasons that it's not as popular as crack cocaine. One of the reasons is that snuffing it in this way is not good for the nasal epithelium. The nasal epithelium does not like cocaine hydrochloride. Cocaine hydrochloride turns out to be extremely toxic to the nasal epithelium and actually causes the cells of the nasal epithelium to die. Okay, so if you snuff cocaine hydrochloride too often, what happens is the nasal epithelium starts to actually die, and indeed it can actually cause the gradual deterioration of the entire nasal septum, the divider in between your two nostrils. Okay, so it can quite badly disfigure your nose if you snuff cocaine for too long. You can lose the nasal septum, and that isn't considered a good look. Okay, so that's one of the reasons that it's not particularly popular, because of the damage that it can do to the nasal septum. The other reason that it's not particularly popular is that it's very easy to adulterate cocaine hydrochloride powder. And what do I mean by that? It's just a white powder. Okay, now people who are selling cocaine hydrochloride want to make as much money as possible. The real stuff, the real cocaine hydrochloride, is very, very expensive. So often what happens is they will pour things like bicarbonate of soda in with the cocaine hydrochloride to bump it out a bit. Okay, so when you buy cocaine hydrochloride, you don't know what you're actually getting. You might just be snuffing talcum powder or something along those lines. So the other problem with it, the other reason it's not that popular, is because it's easy to be conned. Okay, and that's probably another reason that it can cause all sorts of damage to the actual nasal epithelium, because you don't know what's in it. Okay, so Cocaine hydrochloride, not particularly popular. Crack cocaine is far more in fashion with drug abusers. Okay, now let me explain what crack cocaine actually is. Okay, so crack cocaine is literally just a rock of cocaine. Okay, so it is a solid rock of cocaine. Loads of these molecules in a solid rock. Okay, and the way that it is actually used is that you set it on fire, basically. You smoke it, and then when it's on fire, lots of the cocaine molecules will go from being in the solid form to being in the gaseous form. Okay, so you'll get cocaine vapors coming off the crack. Okay, and then what happens is you inhale the vapors, they go into your lungs, and then just like oxygen would, they cross into the bloodstream from your lungs, and then you've got loads of cocaine molecules in your lungs. Okay, and that doesn't seem to cause the same damage to the nasal epithelium as cocaine hydrochloride does, and which is one of the main reasons that it's far more popular. Okay, so those are the two different routes of administration then, the two main forms that cocaine is actually used in. Okay, right, so now what I want to talk about then is what does cocaine actually do? We've now got cocaine in our bloodstream going to our brain. What does it actually do to you? Okay, so there is a fantastic term that summarizes what cocaine is, okay, and it's called a psychomotor stimulant. So I now want to explain to you what is actually meant by a psychomotor stimulant. Okay, so let's firstly decompose this term. So firstly, psycho here. Psycho is short for psychology. Okay, psychology is the study of the mind. Okay, so this is all about the mind. It's all about what you are thinking and how you are feeling. Okay, so you're going to get stimulation to the mind. You're going to get stimulation of your thoughts and feelings. Okay, so psycho means pertaining to the mind. What does motor then mean? Okay, well, motor refers to more behavioural aspects. Okay, and these are the two huge things that are actually studied in psychology. One is the subjective feelings that a person is actually having, the subjective thoughts and feelings, the things that are actually going on inside your head. Okay, the other is behaviour. Okay, and this is a very important distinction in psychology because, for instance, when we do experiments on animals, when we do psychological experiments on animals, all we can actually observe is the behaviour of the animals. We can observe what they are actually doing. Okay, that's all we can observe. We don't actually know what's going on inside their heads. Okay, so a lot of psychological experiments just have to rely on behaviour. Okay, but the other important aspect of psychology, which is an aspect that we can explore if we're working in humans because they can tell us what they're feeling and what they're thinking, is what is actually going on inside your head. Okay, so this is the sort of subjective part of psychology. This is the more objective part of psychology. This is the portion that it's very easy to measure and be objective about, whereas this is just subjective report. Okay, so psychomotor stimulant then. Cocaine is going to affect what you are feeling and thinking. That's the psycho portion. It's also going to affect your behaviour. It's going to affect how you are actually acting. Okay, this portion we rely on what people who have actually taken cocaine tell us about what it actually feels like. This portion is available for anyone just watching someone take cocaine. Okay, they can see how the behaviour of the person changes without actually taking it themselves. Okay, so I'm now going to describe to you then what cocaine actually does to how you feel and what it does to your behaviour. Now obviously I have not taken cocaine in my lifetime, nor do I ever plan on taking cocaine in my lifetime, so I cannot give you a first-hand account of what it feels like to take cocaine. However, I have read about what it feels like to take cocaine, and that's what I'm now going to describe to you. Okay, so what then does it do to your mind, firstly? How does it change how you are thinking and how you are feeling? Okay, well, I'm told that it makes you feel utterly euphoric. Okay, so it causes euphoria. It makes you feel really, really happy, really, really content, and pleasured, okay? So it makes you feel very, very happy. Okay, it gives you an intense feeling of pleasure. Okay, in addition, it makes you feel far more alert and awake. Okay, so the other big thing it does to you is it makes you feel incredibly alert and fast-witted. Okay, so it makes your brain feel as though it's working really fast, like you can do anything. Okay, you feel as though you've got enhanced cognitive abilities. Okay, so alert. Okay, so those are the two big things that it does. It makes you feel incredibly happy and it makes you feel incredibly awake and alert. How does it affect your behaviour then? Okay, well, if you watch someone taking cocaine, what happens is they start moving around a lot more. Okay, so they become far more motile, so move a lot. Okay, in addition, they end up talking a lot. Okay, so they start talking a lot as well. So how much they actually move around and how much they talk goes up hugely. Okay, so those are the behavioural effects of taking cocaine. Okay, so it stimulates your subjective mental function and also your behaviour. It makes you far more alert and far more excited and happy, and it also has a similar stimulatory effect on your behaviour. It makes you do a lot more, you move around a lot more, and you talk a lot more. Okay, and this is the initial cocaine high. Okay. Now, it doesn't actually last that long, unfortunately, because cocaine has a reasonably short half-life in the blood. Okay, it's broken down by the liver extremely quickly. Okay, so the half-life of cocaine, which is written T-half, like so. So this means how long it takes for the amount of cocaine in your blood to half. Okay, so I'll repeat that. The half-life of something is how long does it take for the amount of cocaine in your blood to half. Okay, so just to make some arbitrary numbers up, let's say the amount of cocaine in your blood is 2. Okay, I don't know what the units are, let's just say it's 2. Then the half-life of cocaine will be how long it takes for the amount of cocaine in your blood to go down to 1, basically. Okay, presuming that this scale that I've got is linear. Okay, right. So that's what is meant by the half-life of cocaine. So the half-life of cocaine is around an hour. Okay, so within an hour, the amount of cocaine in your bloodstream will have halved, basically. Okay, of course it does vary for different people, so it's difficult to put an exact figure on it, but usually it's around an hour, so I probably should put around rather than a strict equals there. Okay, right, so what is cocaine broken down into? Okay, well there's 3 main products that cocaine is broken down into, and I'll write these here. Okay, so the 3 main products that cocaine is broken down into are called benzoyl-ecgonine, okay, which is one of the main ones, so you get a lot of benzoyl-ecgonine being produced from the cocaine. In addition, you also get ecgonine methyl ester. Okay, this is the second major one. Okay, so you get a lot of benzoyl-ecgonine and ecgonine methyl ester being produced. A slightly less major one is norcocaine. Okay, so you also do get some norcocaine being produced, but it's not as major as benzoyl-ecgonine or ecgonine methyl ester. Okay, so these are the 3 main byproducts of cocaine, so breakdown products of cocaine. So the liver will break down the cocaine and turn it into these molecules. Okay, and these molecules are then excreted in the urine. And in fact, a little bit of the cocaine is actually excreted unchanged in the urine. I think about 5% of the cocaine is actually excreted directly into the urine. Most of it, however, has to be metabolized into one of these molecules, and then it is excreted in the urine. Okay, and a important correlate of this is that if you're designing a drug test for cocaine, a urine drug test for cocaine, that you can actually design it to test for cocaine itself, or you can design it to test for any of these metabolites of cocaine, and often they test for more than just one of them. So for instance, if you do have a cocaine drug test that's analysing urine, usually what it will do is it will test for cocaine, and it will also test for the metabolites of cocaine. And the reason is that cocaine will vanish from the urine very, very quickly. Okay, so within a few days of taking cocaine, the cocaine will no longer be visible or detectable at all in the urine. Okay, so it will have gone. Whereas these things, the metabolites of cocaine, they remain in the urine for longer after having taken the cocaine.